So for question number 1 here, okay, we have a bus that travels 2,500 meters north in 75 seconds and then turns around and travels at 18 meters per second south for 55 seconds. We're looking for, first off, what's the total distance traveled, and then what's the average velocity of the bus. Okay, so the first thing we need to do is write down our givens, divide it into part 1 and part 2 so that we can keep them straight. Okay, so in part 1, we know the displacement is 2,500 meters north, and we know that the time is 75 seconds. And then in part 2, okay, we know that the average velocity is 18 meters per second south, and the time is 55 seconds. All right, so give them a mark for their givens. Okay, if I want to calculate the total distance traveled, I need to know how far this thing went in part 2. Agreed? All right, so that's my first calculation then. I need to calculate the distance. Remembering that V equals D over T, if I want to solve for D, I would multiply both sides by T. So I'd have T times V. All right, so that's going to be 18 times 55. All right, so that's going to be 990 meters. And it's actually south, but I'm not going to need that for the distance part because distance is scalar. All right, so to calculate the total distance traveled, sorry, give them a mark for that step. Okay, to calculate the total distance traveled, I'm just going to take the distance in part 1 and add it to the distance in part 2. Okay, so I'm going to take my 990 and add it to 2,500 meters, and that's going to give me 3,490 meters in total. All right, so that'll be their third mark. That solves part A. Okay, for the average velocity of the bus, if I want to get average velocity, then I need the total displacement divided by the total time. Does displacement, or do displacement and velocity care about what direction I go? They do. All right, so in this case then, I'm going to take that 2,500 meters north, and I'm going to now subtract the 990 meters south, okay? And that's going to be divided by the total time, 75 plus 55. Okay? Give them a mark if they've got something like that where they showed calculating the total displacement and the total time. All right, so we got 11.6 meters per second as our magnitude. What do I need to add to that? Since it's velocity, north. Velocity is a vector quantity, therefore it must have a vector on it. No. All right, so that's your fifth mark on that. So they got a mark for givens, they got a mark for calculating the displacement in part 2, they got a mark for the total distance, they got a mark for showing average velocity as total displacement over total time, and they got a mark for the average velocity, 11.6 meters per second north. If they don't have a north, it's wrong. Velocity is a vector quantity. If it doesn't have a vector, it's wrong. It's not half off. I don't give half marks. It's just wrong. Okay? It has to have all of that to be right. I don't either. I don't know how you would have got 4.6. You did this? Or did you do something else? That's the difference. Brackets. If you don't do it in brackets, it divides these two numbers here and then adds this and or subtracts, like it does order of operations, right? I don't follow what you did mentally. Okay, good. 1,610. Okay. I don't know what to tell you. That's the answer. Yeah. Yeah, in the end, you got it right. That's what matters. Okay. All right. Any other questions on number one? Okay, so in question number two, we've got running a line drill. Okay, so a basketball player runs forward 15 meters at 10 meters per second. All right, so this looks like a trip with more than one part. All right, so we're going to say the displacement will be positive 15 meters. I'm going to make forward positive. Okay, at 10 meters per second. So that'll be positive as well. And then runs backward 10 meters for 1.1 seconds. Okay, and then runs forward, so there's actually three parts. So 15 meters, and that takes 1.6 seconds. All right, so we're looking for the average speed of the basketball player. All right, first off, givens, 1 mark. If I'm going to know the average speed, what two things do I need? Total distance and total time are the two things I'm going to need. I've got distance and time for 2 out of the 3 parts. I don't have the time for part 1. So that's the first thing I need to calculate. All right, so time is going to equal d over v. So I've just manipulated v equals d over t. So 1 mark for that. Okay, and that is going to be 15 over 10, which is 1.5 seconds. You can give them a mark for that. Okay, so we're up to 3 marks. Okay, they calculated the time for part 1. Now that I have that, now I can calculate average speed. Average speed is total distance over total time. Okay, so that's 3. So this will be 4, whether they showed this or just plugged in the numbers. Okay, so the numbers are 15 plus 10 plus 15 divided by 1.5 plus 1.1 plus 1.6. Why did I not subtract the 10? Right, it's speed, it's scalar, it's distance, it's scalar. Direction doesn't matter, I'm just adding them all up. It's how far I went. Okay, so when I do all of that, okay, I'll get my average speed. Okay, so we've got 40 on the top, okay, divided by 4.2. Yeah, 4.2. Okay, so we're going to get an average speed of 9.5 meters per second. Fifth and final mark on that one. All right. If you can, hand those back to the person with a mark out of 10 on it, and then just bring them up to me once you've had a look at them, please.